Hey guys, today we're going to be doing this problem from the Zoom textbook. It's actually like a conceptual problem, so I thought it's important. But I have basically the dominant equation right here, and we know that in order for a reaction to be spontaneous, delta G must be negative. I don't want to say spontaneous, I want to say thermodynamically favorable. It must be negative, and I'll actually explain why that is. But let's just get straight into it. But I'll explain why that is in a different video, because it'll take me kind of long. Okay, so starting off here, we have they're giving us my enthalpy is positive. Okay, we really don't like to see that, but it doesn't necessarily mean the reaction cannot be thermodynamically favorable. It just means that delta S must dominate negatively to be thermodynamically favorable. Okay, so I'm going to convert this to joules because this is in joules. So this 25 kg, that's the same as 25,000 in joules. So I'm just going to put 25 E3 and then minus the temperature, which is 300 Kelvin, times my, 5 joules? 5 joules. So 25 E3 we already know is 25,000. So from 25,000 we minus 1,500, so that's 300 times 5. I'm also just going to round it just to give the idea. So it's 23,500. I'm just going to put 24,000. I'm rounding here. It doesn't really matter because the idea is that this is very, very, very positive. And even when you subtract from delta H, it's still positive, which means that this reaction is not spontaneous and not thermodynamically favorable. They want us to use this one, so I'm going to try and say that. Okay, so now we have delta H again, but now we have delta H once again positive. Again, delta H as positive is not thermodynamically favorable. Just looking at the term by itself, you don't really want it to be you don't want it to be positive. You want it to really be exothermic, right? So it's because what it really means is that it's gaining heat rather than releasing it. Okay, so now delta G here, let me put that delta G here, is equal to 25,000 minus 300 times 100. Which is what? 30,000. So 25,000 minus 30,000 is obviously going to be a negative number because delta S dominates. So this is the idea here. The term with delta S dominates when the enthalpy is positive, which is the only way that it can be thermodynamically favorable, right? Unless my temperature is really, really, really high or vice versa, right? So now I have a negative 5,000 joules. This is spontaneous, and this is thermodynamically favorable. Okay, now we have delta H negative, which is good. But without looking at G here, we know that this reaction will be spontaneous at all temperatures. Why? This is why. Delta H is negative. This is the concept that they're basically trying to get you to understand. Negative means delta H is thermodynamically favorable, right? It is. It being negative is thermodynamically favorable in itself because it's exo, basically. The idea there is, right? And then delta S is positive. The reason that delta S is positive is because there's the negative T delta S. That term is less than 0, right? So although this term is less than 0, the delta S term right here is positive, right? So basically the 290, okay, so you have basically 298 times 5, right? 298 times 5 is 1490, but then you have that whole negative term. So you basically have negative 1490, right? Then 10 kilojoules, again, we're going to convert that to joules, so 100,000, sorry, not 100,000, 10,000. And you see that here, even when you take away this whole term, it's still negative, which is what you want. But the idea here they're trying to get you to see with no calculation is that here, delta G will always be less than 0 with the sign combination of delta H equals negative and delta S equals positive. This will save you a lot of time on the AP exam too, is what I've heard. If you get this concept, it's really less calculating, more how much do you remember, right? So number D, part D, it asks us here. Okay, so I just realized. Okay, this is in joules, this is in kilojoules, but here we see that we have delta H negative and delta S negative as well. Again, this doesn't mean it can be spontaneous. It just means that there is something we're gonna notice that is like specific to a type of problem, and I'm gonna literally explain that like in a second. But delta G here equals my delta H, which I've converted to joules, minus my temperature, which is 200 Kelvin, times my entropy, which gives me a value of negative 2,000 joules, which is spontaneous. Sorry, this is 2,000 here, which is spontaneous. So an idea I want to illustrate here is I'm going to like literally use this exact problem. I'm going to take you guys to like a couple notes I did. But an idea I want to illustrate that, or like a concept they sort of brief over, is this. So in that last problem, we have that our delta H was negative and our delta S was negative. So they're both negative. And we could see that delta S being negative is not favorable in this situation, because you want delta G to be negative as well. And if both terms are negative, they're going to cancel out if they're being multiplied to each other, right? So what this basically says is that if delta H and delta S are both negative, in order to make it favorable, you must be at a lower temperature. I know I know that 200 Kelvin seems like, oh, what 200 is like, what do you mean? Like that's a high temperature. We have to consider that 200 comes from a value in Celsius plus 273, right? You get what I'm saying? So let's say Celsius was originally whatever 200 is, minus is at the value. So let's say I have 200 and I subtract 273. That was the original value of my Celsius, which is negative 73 degrees Celsius, and that is definitely a low temperature. That's like one of the ideas you have to sort of see. We can actually go through these sort of topics. I know we did one where delta S is positive and delta H is negative. This is the one that's favored on both sides. For the one where both of them are positive, like example, I think that was example 1, right? Yeah, example A. In example A, delta H was positive, delta S was also positive. So in order for this to actually work, it must have high temperatures to be favored. So in section A, it was not favored, but the temperature was also 300 Kelvin. But if we think of 300 Kelvin minus 273, that's 27 degrees Celsius, which is not a high temperature. But let's say right now I said it wasn't at 300 Kelvin, it was at 900 Kelvin, right? I'm starting off with 25,000 joules for my enthalpy. So that's 25,000 joules for my enthalpy. I'm going to put, 25E3 minus, say our temperature is 900 Kelvin times, once again, positive 5 joules for my enthalpy, right? So 900 times 5, okay. 900, I didn't mean to say 900, I meant to say 9,000. And you guys can tell I'm going on a stretch here, but I'm just trying to show an idea. So 9,000 times 5, well, I just think of it as like 45 and add the zeros. So 45,000, 25,000 minus 45,000, and clearly 20,000, negative 20,000 is negative, and it is spontaneous. So that's the idea you want to see.